Hello and welcome to week 9 in Statistics for Psychology. And this is an exciting time in statistics. We're going to start doing some tests. So there's 2 chapters this week, chapters 9 and chapters 10. Chapter 9 introduces you to z-scores, and chapter 10 introduces you to t-scores. Now, let me just take some time to explain a little bit about this. When we are using z-scores, we are using them with standardized data, meaning all the standardized tests that are out there, all the tests, all the data that we have, that we know the distribution, we know what the means are, we know what the standard deviations are of the population, and we're comparing you to the population. In t-scores, we are in the single sample t-scores, we are comparing an individual or group performance to a presumed understood population mean and standard deviation. So let me just talk about z-scores first. Now, z-scores, you've been introduced to the standard curve. And I introduced the standard curve. Not only do we have scores that distribute across the bottom, but we have numbers that indicate standard deviations. Okay, 1 standard deviation plus or minus, 2 standard deviations plus or minus, 3 standard deviations plus or minus. When you have raw scores that distribute, and then you have numbers that indicate standard deviation, z-scores are measured in standard deviation units. So a z-score of 1 means plus 1 standard deviation. It locates. You have a raw score and you convert it to where does it exist in relation to those standard deviations. So all you're looking at is taking your data and converting a score to see where it is on the standard curve in terms of standard deviation. So it can be 1, it can be minus 1.3, it could be plus 0.5, it could be minus 3.6. But the numbers are in standard deviations with the plus going one side and the minus going the other. So all you're doing is converting units. So intelligence, let's say, has standardized intelligence tests have a mean of 100 and a standard deviation. I'm going to throw 15 out there. I think it's 15. So you have the raw score is 100, and the next one up from that is 115, 1 standard deviation. So if I apply that to a z-score, the z-score for 100 is 0. It's the mean. The z-score for 115 is 1. The z-score for 118 is 1.02 or something. It's just, you can see how that score moves along. You're just converting the raw score into z-scores. This is the true benefit of standardized testing. It's very easy. In fact, there's tables and calculations that do it for you. When you use standardized tests, such as the SAT or the ACT or the graduate record exam or any one of the main results, main learning results tests and all that, all you need is the raw score, and you can compare to how well did you do to other people taking that test. Where along the standard deviations are you? So incredibly useful. And that is why you see a lot of research being done with standardized tests. So for chapter 9, I'm having you look at an example. I give you the standardized height and weight for both men and women. Then I give you are not you, the student taking this class, you are playing the role of a 5'7" male at 180 pounds. I want you to calculate the z-score for that individual. If you want to do your own height and weight, that is fine, but make it clear that you're doing that. So that because I'm going to be going in, the answer key for me is the 5'7" male at 180 pounds. That's the answer I'm looking for. If you're using your personal statistics and using the male female, that's fine. You can do that, but tell me that's what you're doing. So that's the quiz. And then the discussion is actually to go into EBSCO again, and in your search, look up an article that uses Z-scores. You just have to put in quotes, psychology article, or your topic. Maybe pick your topic from the first, from reading and writing. Look to see if there's any studies out there that have used Z-scores. These are going to be studies that have used a standardized instrument, or they're using standardized statistics like what you might get from the Census Bureau or something like that, and they're comparing their results to populations that are known. Very, very useful tool, very easy to use. It's sort of the brass ring of testing is to do that. It's not, of course, it doesn't cover everything. That's why we have other tests. But there we go. So that's Chapter 9. In Chapter 10, I draw that difference between when do we use Z-tests and when do we use T-tests. Now, T-tests in this instance, we're looking like I have one score and I'm using a standardized test. I use Z-scores. If I have one score and I don't have standardized tests, I have to make an educated guess as to what the mean is going to be in the population. Now I'm going to give you a trick. When we don't know the population statistics, and I'm using T-scores, I have a result, a group of people that I have a mean, and I don't have the population data. My population data is based on my null hypothesis. So, if I did an intervention and I measured the results of that intervention, and I'm looking to see a change in their score on something. So I've seen a change. In the null hypothesis is there's no change. So if I want to see if my change is significant compared to a population, I'm going to assume the population has no change. So let's say I'm looking at a 3-point change. What's the expected mean? 0 change. So you're looking at the null hypothesis. Now, when we're dealing with chance, flipping a coin or rolling a dice, or some things that are pure chance, we have to go back to probabilities. So when let's say I'm holding 4 cards and I'm going to test your ability to read my mind, because there's shapes on the cards, kind of a classic ESP sort of test. And I'm gonna, and you know what they are. There's a circle, square, triangle, and a cow. I have those things in front of me, and I say, which one am I pointing at? You have a 1 in 4 chance by pure chance. So a 25% chance of guessing the right one. That's your null hypothesis, is 25%. Anything above that would consider there's something else going on. So you have if you believe in ESP, and I have the ability beyond chance to be able to select the right card, then my success rate has to be better than 25%, because 25% is the null hypothesis, meaning you're just getting them by 1 in 4 chance. Think about that. So when you're looking at the single mean t-test, consider the null hypothesis. What are the chances when there's nothing going on? And in probabilities, that's where you get that. What's the probability of being right in terms of, the raw information that's in front of you versus your alternative hypothesis, something's going on, it needs to be different than that. Okay, so in there's only one assignment, very similar to what I just described, looking at subliminal processing. I give you the data. Now, this is an individuals who've been tested to see if they recognize subliminal images, so it gives you the percentage of time that they're correct. What's the null hypothesis? That's almost the key part of doing this assignment, is what is the expected chance if there's nothing going on, if subliminal perception is not there, what would you expect the chances of people guessing are on that? That's the critical thinking question that will get you right through this assignment. Because then you just plug those numbers into the formula and you can get the t-score to see whether or not among this population and among this sample of people, whether or not they actually did experience a significant degree of subliminal perception. So have at it. It'll give you the likelihood of that happening. So chapters 9, we have a discussion and a quiz having to do with z-scores. In chapter 10, we just have an assignment. Okay? This is a tough one. This is formative stuff because from this point on, we're going to launch into t-tests where we're comparing groups. Probably the most common of the research methodologies that we have is comparing one group to another using the different t-tests. So that's going to be how we finish off the whole course. We're in t-test, then we go into ANOVAs, and that kind of is how we flow through this particular class. So this is an important turning of the curve, turning the corner on this class where we look at z-scores, and then the next best thing is the t-score, where we're making assumptions about a known probability, and then we'll go in the following weeks, we'll be getting more into the comparing groups with the independent and dependent samples t-tests. So that's it for this week. So enjoy the week. It's rainy right now, rainy and cold, kind of a weird time of year in Maine, and a weird time in Maine. I hope you're well. I hope hold your loved ones close, and have a great week. And again, if there's any confusion about things, make sure you reach out to me early in the week, and I can help you with those particular areas. So I look forward to seeing you folks in the discussion boards, and have a great week.